So this video is going to help you with the lesson on mean absolute deviation. Our learning target today is I can calculate the mean absolute deviation. That we call it MAD for short. Well, first of all, let's figure out what is the mean of this data set. So go ahead and pause the video and figure what the mean is. I will meet you back here in a little bit. Okay, welcome back. So just to review, when we talk about the mean, that is just a fancy name for average. So we have to add all these numbers up. 5 plus 7 plus 8 plus 12 plus 13. Now what do we get when we, 13, when we add all those together? Well, there's 12, 20, 32, 45. 45? I get 45. Now, how many numbers did we add together? Let's see. 1, 2, 3, 4, 5, 5. So that's what I divide that by. I take my 45 and I divide it by 5. You can do that in your calculator, or if you know your multiplication and division facts, you know it's 9. So the mean of this data set is 9. Now we're going to use this a lot in this lesson. Let's review though what absolute value means. If you think back, way back, absolute value just means how far away is this integer or number from 0. If you make a number line, here's 0. Here's -5. And here's +5. They're both 5 bunny hops away. 1, 2, 3, 4, 5 from 0. 1, 2, 3, 4, 5. They're both 5 bunny hops away from 0. So when we talk about absolute value, we're just talking about distance on the number line. Our fancy brackets, they're straight brackets here, tell us that we want to know what the absolute value of 5 is. Well, we just figured that out. It's 5. What's the opposite value, absolute value of -13? Well, you just drop the negative sign. It's 13 bunny hops away from 0. What about 2? What's the absolute value of 2? It's 2 bunny hops away from 0. Okay, you can pause the video and figure out the rest of these by yourself. And I'll see you back here in just a little bit. Okay, welcome back. I hope that you were able to figure out the absolute value of the rest of these numbers. And you see a pattern. They're all positive numbers. Because when we talk about distance, we talk about distance in the number line. Let's break down what mean absolute deviation really means. All right, we know that the word mean is the average. Right here, it's the average. We know that the absolute value is the distance away from 0 on a number line. The only word that we might have a problem with is deviation. And the word deviation means something different from the normal. Not normal, something that's totally different. So the mean absolute deviation in math is the average distance of each data value is from the mean. Remember, we'll find the mean of the whole data set, and then we're going to figure out the average distance that each data value is away from the mean. So when we talk about mean absolute deviation, we use that number to analyze the spread of the data. If you have a high or a big number, then that means the data is more spread out and you won't have as much predictability there. If you have a low or small mean absolute deviation number, then that means the data is closer together and you'll be able to be more confident that your conclusions and your predictions will actually happen. Now there's a video you can watch in the classroom, so go ahead and watch that video and come back here and we'll talk about how to find the mean absolute deviation. Okay, let's figure this out now. If we got to find the mean absolute deviation of a data set, here is our data set: 3, 6, 6, 7, 8, 11, 15, and 16. Our very first step is to find the mean of the whole data set. So we're going to add those together. When we add all those numbers together, we get 72. And we added 8 numbers together. 1, 2, 3, 4, 5, 6, 7, 8. We're going to divide that by 8. And our mean or average of the whole data set is 9. Now this is where we have to start. Now I like to put, that in a box. Alright, I like to say, okay, well I know that my mean is 9. Now I'm going to see how far away from 9 each one of these data points are. 3, 6, 6, 7, 8, 11, 15, and 16. So all I have to do is subtract the first data value, 9 minus 3. It's 6 bunny hops away from the mean. That's where I get this number here. 6 is our next data value. 9 minus 6 equals 3. It's 3 bunny hops away from 9. I do 6 again. Now, our next data value is 9. 9 minus, or is 7, I'm sorry. That is 2 bunny hops away. Do you see what I'm doing? I'm subtracting all these numbers from 9. 9 minus 8 is 1 bunny hop away. Now here's where it gets a little bit confusing. If you have 9 and you subtract 11, you are going to get a negative 2. But remember, when we're talking about distance on a number line, we're talking about how many spaces away from 0 it is. So we take the absolute value of negative 2 and we come up with 2. See, it's 2 bunny hops away. 1, 2, when we're talking about distance. So when we take 9 and we subtract 15, we're going to get a negative 6. But we want the absolute value of that negative 6 because we're talking about distance away from 0, and it's 6 bunny hops away. The same thing with 9 minus 16. That's going to be a negative 7, but we want the absolute value of negative 7. That's where that absolute comes in. Mean absolute deviation. So that's our second step, is to find the distance away from the mean for each value. And how we do that, we take our mean value, this is our mean value here, and we subtract every one of those values of the data set away from the mean. I like to set up a table, you know, just like this is here, to keep everything straight. But let's look at it, the points on the number line. All right, here is our mean, right here. And each one of those data sets, each one of those sets of data, 6, 3, 3, 2, 1, 2, 6, and 7, that's how far away they are from the mean. We figured that out over here on this table. Here they are, 6, 3, 3, 2, 1, 2, 6, and 7. It's just showing that here on the number line. To find the average of that, this is where we're coming up with our mean deviation. We just find the mean of all of those numbers, the distances from the mean. So we add up all those numbers and we come up with 30. Those are the numbers here, the distance from 9. We added all these together. And we added 8 numbers together again. So when we divide our distance from 9 divided by 8, we get 3.75. That is our mean absolute deviation. Really what that's saying is this is the average distance away from 9. So it's 3.75 average. So that's a smaller number. And that means that our data set, that our original data set that we had here, our original data set here is pretty accurate. We can be very confident in our predictions and our conclusions from this data set. All right, now I went through that pretty fast. We're going to go through another one slower. Here are the steps to find the mean absolute deviation. You might want to pause the video, take a screenshot of it, write it down, however you want to save it, and put it in your math notes. So the steps are, you have to find the mean of the whole data set first. Step number 2, you subtract each value of the data set from the mean. This is what you found over here in step 1. You drop the negative sign. Well, when you put it in your calculator, you drop the negative sign because distance is always positive, and that's the absolute value. Step number 4 is you have to find the average of all the distances away from the mean. So that means you add up all those numbers again and divide by how many numbers you added. This will be your MED. Set a table up to be more organized. This is how I set up my table. Alright, so this is step number 1 here. Find the mean. This is step number 1. This will all be the same number. These will all be the same number. Step number 2. This is step number 2. You're going to subtract, okay, you're going to put your data values over here. I'm going to say D for data values. Then you're going to subtract your D minus your X. This is going to give you this value here and here. Then you drop the negative sign. This is number 3. These are all positive numbers. You're going to add all of these together. You're going to add all of column 4 or 3 together. This is your step number 4. And then you're going to divide the total of the absolute values, this total right here, you're going to divide it by your numbers. And you're going to come up with this number here. That's your mean absolute deviation. All right, let's look at this data set. Here's your data set. All right, 7, I'm just going to write those numbers in here. 7, 2, 5, 1, 2, 7. Notice they're not in order. That doesn't need to be in order if you don't want it to be in order. It's okay. But I add all these numbers together and I divide by 1, 2, 3, 4, 5, 6. I divide by 6 and I get a mean of 4. This is step number 1. Step number 2 is I subtract each value from the mean. So you can see where I have done that here. 7 minus 4, 2 minus 4, 5 minus 4, 1 minus 4, 2 minus 4, and 7 minus 4. And there's those numbers. That's the deviation. That's how far away it is from the mean of 7. Each one of these values. I drop the negative sign. This is step number 3. So you see all these numbers are positive numbers, right? Okay, you add these all together. This is your step number 4. You add all of these together and you come up with 14. Now, because you added 6 numbers together, you're trying to find the average of this. All right, so I divide it by 6. Now, you're going to probably get a decimal number. Okay, so I want you to round to the nearest tenth always. That's the first decimal place after the whole number. And that's your MAD right there. MAD absolute deviation. Now look, it's a low number. All these numbers, all the data here, you can be confident in the fact that any conclusions that you come up with for your data is going to be correct. All right, now this is a lot of work. You have to persevere. All right, we're going to go through one together. All right, you can use a calculator. The gardener counted the number of blooms on 10 flower bushes and then arranged the numbers from smallest to largest. The blooms of each bush were 4, 4, 6, 6, 7, 8, 8, 8, 9, and 10. The mean of these measurements is 7. Right there. You don't have to figure out what the mean is. It's telling you that the mean is 7. We want to know what the mean absolute deviation is. Well, the first thing we have to do is figure out how far from 7 each number is. Each one of our data points. So here's where we're subtracting. All right, we go through all of the numbers on our data set. 4, 4, 6, 6, 7, 7, well, wait, 8, 8, 8, 9, and 10. So there, we figured out how far away they are from 7. Now we add all of these numbers up. You add these up. So 3 plus 3 is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I get 16. Let's try it again. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. I get 16 altogether. And how many numbers did we add? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. We added 10. So if we take 16 and divide it by 10, what am I going to get? Bingo! I'm going to get 1.6. Because I added those 10 numbers, that's what I have to divide by. Bingo! We just got this is our MAD. That's our MAD. Our MAD. Okay? Let's try another one. Round your answer to the nearest tenth. So here, I've put all my data values in here. So let's find the mean of this. If we add up all these numbers, 36 plus 59 plus 32 plus 18 plus 40 plus 25, what do we get? Pause the video and see if you can get that on your calculator. Okay, well, welcome back. You should have gotten 210 when you added all those together. Now you have to find the average of that. So you had 6 numbers that you added. You have to divide that by 6. And I hope you got 35. Alright, so I'm going to put 35 in each one of these boxes, because that's our mean of the whole data. Okay? Now we just subtract. 36 minus 35 is 1. 59 minus 35 equals 24. 32 minus 35 is negative 3. 3, 4, 5, yeah. 18 minus 35 is negative, let's see, 3, 8, 3, 23. I believe so. I'm going to check that on my calculator because I'm not sure. 18 minus 35, 17. Wait, 18, 17. Oh, see? That's wrong. This is wrong. This is 17. Negative 17. And then 40 minus 35 is 5. And then 25 minus 35 is negative 10. Now, I drop my negative signs and I just recopy everything here as positive numbers. Now, our next step is to total all that together. So make sure you add 1 plus 24 plus 3 plus 17 plus 5 plus 10. I hope you got 60. We added all of those together. Now, how many numbers did we add together? 1, 2, 3, 4, 5, 6. We added 6 numbers together, so I'm going to divide 60 by 6, and I get what? I get 10. 10 is our MAD. That's our deviation. Absolute value deviation. Mean absolute deviation. That's kind of a high number. I'm not sure I would trust my data. All right, so in today's lesson, you have to calculate the mean absolute deviation using IXL. The quick find number is JUV. I want you to spend your whole 30 minutes on this because you're going to need it. Try your hardest. Set up your table just like I showed you in the video. Okay, it doesn't have to be perfect. But look, you can have 1, 2, 3, 4, 5 columns. Right? 1, 2, 3, 4, 5 columns. And start putting your data in here. And then subtract here. Drop the negative signs. And then add all these together and divide by however many numbers you have in your data set. You guys can do this. I know it's a long process, but you can do this. You have all the skills that you need. I have confidence in you. All right, people. It's time to take a break. You can go ahead and log out and work on that IXL. Bye.